Free response number 2 is asking you to find convergence and the interval at which this series converges over. So it gives you the summation from n equals 4 to infinity of sine of x to the 2n over 3n squared. So this x value can be technically any real number, but we need to figure out what x values will actually satisfy the convergence for this series. So first off, we need to find a way to figure out if it converges in general. So I have 2 to the n power, and I have 3 to an n squared on the bottom. What that tells me is I'm probably going to use root test to figure out its convergence. So I'm going to go ahead and apply root test. L is equal to the limit as n approaches infinity of the nth root of the absolute value of a sub n. I go ahead and apply that formula. I end up getting the limit as n approaches infinity of the nth root of sine of x to the 2n over 3 to the n squared, and then I'll have that to the 1 over n power. So now if I go ahead and simplify that out a little bit, limit as n approaches infinity, I end up with sine of x, quantity squared, over 3 to the n. Now, I still have to take the limit of this as n approaches infinity. This term up here has no dependence on n. X is a number. So in this case, the only term that has any dependence on n is just this bottom one. So if I take the limit of this as n approaches infinity, all it's going to do is go to 0. Now, according to the rules of root test, 0 is less than 1, so this series should be absolutely convergent. But again, we were trying to figure out what values of x will satisfy this equation and make it convergent. Well, the thing is that no matter what x value I plug into here, the bottom will never change, nor will this ever become dependent on n. So therefore, whenever I take this limit, regardless of what x is, it will always be 0. So therefore, because 0 will always be less than 1, no matter what for this series, my x value can be anything from negative infinity to infinity. So regardless of the number I plug into there, I will always have convergence. So the interval of convergence is x is greater than negative infinity to infinity.
The Teaching Center, UF's Learning Resource Center.